I'm one of the members of Group 9. In this class, the goal was to develop and build a device that can hit a golf ball at a targeted area. There is a green that's 10 feet and a fairway that is 20 feet. The device has to be loaded by a single person, it also has to be carried by a single person, and has to be under the maximum budget of $40. The device is restricted to a size limit of 2.5 feet by 2.5 by 2 feet. It must store energy and release it by a trigger mechanism. In our project, it's a pin. Batteries, motors, chemical reactions, and commercially available devices are prohibited in this competition.
Hi, I'm Scott Hoffman, and I'm also in Group 9. Our competition will be held on December 11th at 8 a.m. The competition will be a single elimination tournament where each round 4 teams will be competing and the best team will go through. This will be determined by total shot points minus the cost of the device. Each team can set their own shot distance and will be judged on their accuracy and how far the ball goes. If the device is determined to be unsafe, the group will be kicked out of the tournament, lose shop access, and the grade will be penalized.
So this is our device. We first started with a plank of wood that's 6 inches by 2 inches by 2 feet, which fits in the size requirement by definition of the project. Here is a PVC pipe, which we've cut a slot into for the contact head to go back into. We have drilled 2 holes in the top, one for a screw, which you can't see because we've duct taped the PVC pipe down for extra support. And then we have this other hole here for the pin to slide down into. Moving on, we have drilled a hole here so the tee can be placed down into the grass. We have springs, 2 on the front that can be pulled back on each side, and we have hooks here in the front which attach it to the wood.
The day of the event, the device has to be loaded by a singular person. And then, in order to do that, first you place the arms of the contact head into the holes on the spring. Then, you place the pin so it's barely sitting in the hole. And you grab the sides, pull it all the way back, so past the contact head, then you knock the pin down into place.
Hi, I'm Baxter Hunt, and I'm in Group 9. I was in charge of the creation of the contact head, which I'll show you now. This was the original prototype for the contact head. It had a 45-degree angle in the front where it would make contact with the ball, and it had 2 arms in the back and a place here for the pin to be put into place. As you can see here, the support was not very good and the print was incomplete. We then moved up to a more structurally sound print that was printed on the back side, so like this. The arms were thicker and stronger. It was able to load properly, but on impact with the springs, our design failed. It broke on impact. There was different models. This is a 5-degree head and this is a 10-degree head, and we figured that would be just not enough vertical velocity after we hit the ball. So we then upgraded to the final design here, which we have a 38-degree head and a 25-degree head, which we tested to see which would go the furthest distance. We added supports here as wings on the side so that when the ball was launched, it would stay structurally sound.
We're out here in the rain. I'm Justin Hessler, and we're going to test our device to the river. Right. So you take our springs here and you attach it to the arms of our contact head. You take our contact head and you pull it back through our PVC pipe all the way to the back, and you slide the pin in place. So right now our device is armed. So now you take the tee, you slide it into our hole. So we're sticking up just a bit. Then you take our ball, you place it on the tee. Once up. We will now fire our device.